All right, recalling our properties of radicals and exponents. This lesson is going to kind of we're going to use what we learned in lesson 38 and 39, and we're going to kind of do everything together. So we're going to see rational exponents, we're going to see fractional exponents, everything. So here we go. We're going to use our properties of radicals and exponents in this lesson. So just a review of all your properties. You know, when you multiply, you add the exponents. When you're dividing, you subtract the exponents. When you're raising, you multiply the exponents, so on and so forth. There's a quick review for you right there. So we're just going to get into some examples. And again, just a reminder, you're not learning from the video. You're just getting information from the video to do your work in class. You're really learning when you are doing them. So if you want to just try a couple of these on your own. So if I do a couple, you might want to try the next one by yourself. That's up to you. But until you really do the work in class, you're not really going to be getting it. All right. So make sure you're paying close attention so you'll be able to do that. First one here, b raised. These are all raised. I know it doesn't look like exponents. Well, I guess it kind of does, but they're not the greatest. They'd probably be a little smaller, but it's b to the 1/3 times b to the 4/3. So multiplying, so we're going to add exponents. That's b to the 1/3 plus 4/3. All right, so we're going to put that in parentheses. b to the 1/3, that's a 3, plus 4/3. So now put it together. You don't want to leave a binomial. You never want to leave a binomial exponent. So we want to combine, well, just add. We have a common denominator, so we're going to add them. That's going to give us b to the 5/3. b raised to the 5/3. There you go. Okay, so that's pretty simple. Dividing, so we're going to subtract the exponents. b to the 3/5 minus negative a half, so plus a half. Minus a negative is plus. You should know that by now. So that's going to give us b to the what? Well, on the side here, we got to do 3/5 plus a half. And of course, you need a common denominator. Times 2, times 2, times 5, times 5. So this is 6 and 5. 6 and 5 is 11. 11 over 10. 10 is the common denominator. So b to the 11/10 would be the answer there. So now we have 1 over b to the 4/3 to the second. So what I'm going to do first is I'm going to do this. I'm going to do the bottom. So it's going to be 1 over. Raise 4/3 to the second. That means 4/3 times 2. That's 8/3. That's 1 over 8/3. And then, 1 over b to the 8/3. And then we want to write it in this form right here. So all we got to do is understand that 1 over is one of our properties, and you have 1 over. When you have 1 over, that is this. So 1 over x to the a is x to the negative a. Just apply that property, the negative exponent property, to write b to the negative 8/3. So in this one, we had to apply two properties. We raised a power to a power. We applied this property, raising a power to a power, we multiply. And then we applied the negative exponent rule, moving it up so it's written in this form, which is what they wanted, b to the m over n form. Okay. Example 2. We have 2x to the 1/2 times 4x to the negative 1/2, so we're going to multiply. 2 times 4 is 8, and that's x to the, 1/2. And then add negative 5/2, so 1/2 minus 5/2, it's like plus a negative. So that's going to be 8x to the what? 1 minus 5 is negative 4, negative 4/2. And that's 4 over 2, which is negative 2. So 8x to the negative 2 would be simplified. 8x to the negative 2. Simplify each expression is what you want to do. You want to get it in the kx to the n form. 8x to the negative 2, kx to the n. There's that form. All right, so now we have part B. We have we're going to raise everything in the negative 2, so it's going to be 3 to the negative 2. And then x to the 1/4 times negative 2 is negative 2/4. which I'm going to write that out, negative 2/4. Now negative 2/4 reduces to negative 1/2. And this is 1/9. We should know by now raising to the negative exponent, put it under 1. So this is 1/9 x to the negative 1/2. And that's the form they want. 1/9 x to the negative 1/2. That would be k x to the n form. All right, this one here, we got some work to do. We're going to distribute. So 2 x to the, now 3/2 plus 1/2 is 4/2. So this times this here is 2x to the 4/2. You have to add the exponents. Minus, and then we're doing this times this here. That's going to be 8x to the 3/2 plus negative 1/4 is, or negative 1/3. So we have to do 3/2 minus 1/3 there. Okay, so we get, this is 2x squared. That's 2x squared because 4/2 minus 8 what? Well, 3/2 minus 1/3. 3/2 minus 1/3 is 3/2 minus 1/3. We're going to go times 3 times 3 times 2 times 2. That's 9 minus 2. So 7/6 x to the 7/6. So 2x squared minus 8x to the 7/6 would be that one right there. Okay. Now notice you can't combine because you don't have the like terms there. Same thing here, you don't have like terms. All right. Recall these properties here. X to the a over b is x to the a radical b, the b root. Okay, power over root. The a is the exponent, the b is the root. And there's another way of writing it. So just recall that from our other lesson. We got some more examples here. Simplify each expression. So here we go. What we're going to do here is we're going to write this as x to the 1/2. And we're going to write this as x to the 1/3. And now we're going to do what we just did in the other examples. X to the, well, add them. 1/2 plus 1/3. We'll just do that on the side. 1/2 plus 1/3. Common denominator. That's going to be 5/6. So it's going to be x to the 5/6. All right, with our common denominator there. All right. Next one, this would be x to the 5/2, x to the 5/2, divided by x to the 2/3. And that's going to be x to the 5/2 minus 2/3. 5/2 minus 2/3 times 3 times 3 times 2 times 2. 15 minus 4, so 11. 11/6. So x to the 11/6. And that's the kxn form. All right. This one here, we have x to the 7th, square root of x to the 7th, and then the cubic root of that. So we have x to the 7/2. Remember, this is a square root here, x to the 7/2. That's what this is right here. And then we do the cubic root of that. That's raised to the 1/3. That's what this means right here. X to the 7/2 raised to the 1/3. Just got to think about those properties. And now you're multiplying. That's x to the 7/6. X to the 7/6. We have to know how to add and we have to know how to multiply fractions very well. All right, so this is x to the 1/2 over 4x squared. All right, so there's a 1 there, so that's 1/4. You got to write it as kx to the n. So that's 1/4. And then x to the what? Well, 1/2 minus 2. 1/2 minus 2 over 1. Common denominator. This is 1 minus 4. 1 minus 4 is negative 3 over 2. So negative 3 over 2. 1/4 x to the negative 3 over 2. And then we have 2x to the 4th minus x squared over radical x. Now, remember, when you have, this is kind of like distributing a division. This radical x goes into both. So this can be written as 2x to the 4th over, this is x to the 1/2. Radical x, you should know that that is x to the 1/2 by now, minus x squared over x to the 1/2. That's a 1/2. Doesn't look like it. That's 1/2. Okay, and now let's see what that comes out to be. So that's 2. 4 subtract a half. 4 minus a half is 3.5. Okay, so that's going to be 7/2. So 2x to the 7 over 2. See how I did that? I just did 4 minus a half is 3.5, and I know that 3.5 is 7/2. You could do the way I did all the other ones. You could do it the same way. Minus 2, and then it'd be x. 2 minus a half is 1.5. That's 3/2. So I have 2x to the 7/2 minus x to the 3/2, and because I don't have a common, you don't have the common power there, like terms, you have to leave it like that. Okay. Show that this expression is equal to 4. Show that this is all equal to 4. Well, that's not hard to do. These are kind of like, these are like algebra proofs. Algebra, we're going to call this an algebra proof. You're going to have to do a couple of these on your lesson. This is an algebra proof. Remember geometry proof, statements and reasons? This is just, they're giving you something and they're saying show that it's equal to something else. So prove, in other words, that this is equal to 4. So this should come out to be 4. 2 to the n times 4 to the n plus 1. Well, what do? Well, we're going to get a common base here. So I don't have, right now I don't have a common base. 4 can be made as 2 squared. So what we're going to do is make this 2 to the n times 2 to the 2n plus 1. Now think about what I just did there. 4 is actually 2 squared. So all I did was change the 4 to a 2 squared. I know this might be a little over your head. It's okay. Now I have 2 to the n times 2 to the 2n plus 2 after I distribute. Now that's going to be 2 to the 3n plus 2. Okay? n plus 2n plus 2. So I have this. Now, I need to multiply by 1/8 to the n. 1/8 is 2 to the negative 3. It's 2 to the negative 3. So I'm going to write 1/8 as 2 to the negative 3, and I still have that n there. Now look what happens. So I just rewrote this as 2 to the 3rd. It's 2 to the negative 3, and the n is there. Now, since I'm multiplying, I'm going to add the exponents. I get 2 to the 3n minus 3n is 0, 2 squared, and that comes out to be 4. So what I did is I just proved that all this comes out to just be 4 when you multiply it. I know that was a little bit over here because we didn't really do the changing of the base with the 4 becoming 2 squared, but that's how you can do that. Power 10. Multiply radical 10 by 10 to the n. So radical 10 would be 10 to the 1/2. Multiply that by 10 to the n. Okay, so I'm going to add exponents. That's going to give me 10 to the n plus a half. That's going to give me 10 to the n plus a half, and I can't do anything more than that. So that's all we're going to do there. Divide 100 times 10 to the n by, so 100 times 10 to the n, 100 is 10 squared. So I have 10 squared times 10 to the n. That's going to be 10 to the n plus 2, because I add the exponents. Divide that by 10 to the 2n. Okay, now I'm subtracting. That's going to give me 10 to the n minus 2n is negative n, and then plus 2. So you're subtracting the exponents now. So here we are adding the exponents, then we go to the division because it says divide, and then we're subtracting the exponents, n minus 2n. All right, we're getting there. Oops. Oh, hit the wrong thing. everything. Okay, almost there. A couple more examples and we're done. Use properties. Okay, now we're raising. This is going to be, we have to multiply these, so it's going to be 3 to the 1 plus radical 5 times 1 minus radical 5. Why am I multiplying? Because I'm raising it, raising a power to a power. Well, guess what? These are conjugates. I know how to multiply 1 plus radical 5 times 1 minus radical 5. We should know that by now. So we're playing on things we learned earlier in the year. This is going to be 3 to the what? 1 minus 5. That's going to be 1 minus 5. 1 minus 5, and that's going to be negative 4. So that's going to be 3 to the negative 4. And then that's going to be 1 over 3 to the 4th. And that's going to be 1 over 81. That's going to be 1 over 81. So for this one here, you get 1 over 81. This one here, now we're multiplying, so we're going to add the exponents. That's going to be, this one's going to be 3 to the 1 plus radical 5 over 2 plus 1 minus radical 5 over 2. So that's going to be 3 raised, and that's all like in parentheses, 3 raised to the 1 plus, we have a common denominator, 1 plus 1 is 2, and then radical 5 minus radical 5 is 0, and then over 2, because you keep the denominator. Now look what just happened. So 1 plus 1 is 2, the denominator stays 2, 2 over 2 is 1, this becomes 3 to the first, which is just 3. So this ugly stuff there just is equal to 3. Okay? Almost done. We have a couple exponential equations we're going to do here. X to the 2/3 minus 5. We're going to add 5 to both sides. So we're going to solve these just like regular equations. X to the 2/3 equals 16. Now, how do I get it to just be x? I don't want x to the 2/3. I just want x. What you do is you raise it. Remember, if it was like x squared, we would take the square root. Well, in this case, it's x squared, so we're going to take the square root. That's like raising it to the half. And then, since it's 1/3, we're going to cube it, do the opposite. So what we're actually going to do is raise it to the third, and then take the square root. So we're actually raising it to the 3 over 2. That's the reciprocal exponent. Whatever you do to one side, you do it to the other. So we're going to raise both sides to the 3/2 power. That's going to cancel out, give me a 1. X equals 16 to the third. Well, I know that this means 16 to the third, and I know it means square root because that's what the 2 means. Square root of 16 is 4. 4 to the third is 64. So this is going to be 64. 4 to the third is 64. You could put that in your calculator. You could put this in your calculator, honestly. All right, same thing here. We're going to add 15. So I have x minus 4 to the 3 over 5 power equals 27. Now raise both sides to the 5/3. Raise to the 5/3. What that does is give you, this becomes a 1. So this is x minus 4. That's all that's left is x minus 4. 27 to the 5/3. Well, I know 27, the cubic root of 27 is 3. So it's really just 3 to the 5th. Cubic root of 27 is 3. 3 raised to the 5th. And then we're going to add 4. So we have to add 4 to both sides. So I'm going to get x equals 3 to the 5th plus 4. Whatever 3 to the 5th is plus 4. I'll grab a calculator, right? Should have done this ahead of time. 3 to the 5th plus 4, 247. 243 plus 4, 247. And that's it. I'll see you tomorrow for more practice.